These biking, strolling, rolling dummies take the hits so you don't have to. They exist to make sure the pedestrian avoidance systems in today's modern cars work. That is, when a kid runs out into the street from behind a car, or a cyclist pedals into a blind spot unseen. The car takes notice and intervenes, braking or evading suddenly, likely saving the life of the pedestrian you didn't notice. You can trust your car will do the right thing when the moment comes. That's because before you took the wheel, it may have already avoided hundreds of kids and dozens of bicyclists, those human-like dummies clad in blue pants, indifferent to the cars barreling in their direction. Advanced Driver Assistance Systems, ADAS. They're the technology that enables your car to brake, change lanes, or swerve around obstacles in emergency situations. They're made by different companies, and therefore operate to different results. That's why organizations like the European New Car Assessment Program and the National Highway Traffic Safety Administration in the United States impose rules that all manufacturers have to stick to on their ADAS tests. The rules demand a certain speed, impact location, and lighting condition, among other specifications. And that's where the Soft Pedestrian Target, or SPT, comes in. The pedestrian target sits on a robust pad or platform. The pad carries a control system that synchronizes the pedestrian with the test vehicle, meaning that in 100 tests, the pedestrian would arrive at the same place in front of the car, at the right time, at the right speed, and at the right angle, every single time. The pedestrian target enables manufacturers to reliably comply with highly specific testing protocols, repeatedly. This is James Buck. He's a senior project engineer at AB Dynamics. He walked us through a test scenario using the SPT system.
The test being shown here is as described in the 2018 Euro NCAP Vulnerable Road User Test Protocol, whereby the subject vehicle is driving and a child suddenly runs out from behind two parked cars. And this test determines whether the vehicle's ADAS system reacts quickly enough in order to avoid hitting the child.
For this scenario, the soft pedestrian target is set to run perpendicular to the subject vehicle.
Since the Euro NCAP protocol requires the subject vehicle to be driven in a very specific manner, you need a driving robot to ensure that the path following and the speed of the vehicle remain within tolerance. The driver in the subject vehicle has now activated the robots and the vehicle is following the specified path and speed profile. When the vehicle is at the correct distance from the impact point, the soft pedestrian target system initiates the movement of the platform. This automatic triggering guarantees that the impact point is as described in the protocol, unless of course the vehicle brakes automatically in order to avoid the dummy. In this example, we've disabled the ADAS systems in the vehicle such that the vehicle will strike the target.
The contribution these dummies make to keeping our pedestrians safe is pretty clear.